Physics Part 117. Because the molecules are moving randomly, the potential energy of a given molecule will also vary randomly. But at a given temperature, the total potential energy of all the molecules will remain constant. If the temperature changes, the total potential energy will also change. Furthermore, the molecules of a real gas collide with each other and will interchange kinetic energy during the collision. For this real gas, the internal energy is given by the sum of the potential energies and the kinetic energies of all the molecules. It is important to realize that looking at a single molecule will give us very little information. Its kinetic energy will be changing all the time as it collides with other gas molecules, and its potential energy is also changing as its position relative to the other molecules in the gas changes. This single molecule has a kinetic energy which is part of the very wide range of kinetic energies of the molecules of the gas. We say that there is a distribution of molecular kinetic energies. The distribution is illustrated in figure. Similarly, there is a distribution of molecular potential energies, but by adding up the kinetic and potential energies of all the molecules in the gas, the random nature of the kinetic and potential energies of single molecules is removed. The idea of internal energy can be extended to all states of matter. In a liquid, intermolecular forces are stronger as the molecules are closer together. So the potential energy contribution to internal energy becomes more significant. The kinetic energy contribution is still due to the random motion of the molecules in the liquid. We can think of a solid as being made up of atoms or molecules which oscillate, vibrate about equilibrium positions. Here the potential energy contribution is caused by strong binding forces between atoms, and the kinetic energy contribution is due to the motion of the vibrating atoms. The concept of internal energy is particularly useful as it helps us to distinguish between temperature and heat. Using an ideal gas as an example, the temperature is a measure of the average kinetic energy of the molecules. It therefore does not depend on how many molecules are present in the gas. Internal energy, again, for an ideal gas, however, is the total kinetic energy of the molecules, and clearly does depend on how many molecules there are. In general, heat refers to a transfer of energy from one substance to another, often as a result of a temperature difference. If two objects at different temperatures are placed in contact, there will be a flow of heat from the object at the higher temperature to the one at the lower. The direction of heat flow is determined by the difference in temperature, not by any difference in internal energies. If 10 grams of a liquid at 30 degrees Celsius is placed in contact or mixed into 100 grams of the same liquid at 20 degrees Celsius, the direction of heat flow is from liquid at 30 degrees Celsius to the liquid at 20 degrees Celsius. Even though the liquid at 20 degrees Celsius has a greater internal energy than the smaller mass of liquid at 30 degrees Celsius. Next, we talk about the laws of thermodynamics. And in fact, we'll start with the first law of thermodynamics in our next video.